In this video, I'll talk about the derivation of Marshallian demand functions in case of perfect complementary goods. So the perfect complementary goods are those goods that have to be consumed in some fixed ratio. So for example, if every unit of x2 should be consumed with 2 units of x1, in this case these two goods are called perfect complements. So in such a case, the indifference curves will look like a right-angled indifference curves as shown in this figure. These are also called Leon-Tip preferences. So Leon-Tip preferences. So we discuss here the derivation of Marshallian demand function in such preferences. So in this case, the consumer's equilibrium will lie in the corner point of this right-angled indifference curve where derivative is not defined. So we cannot use the Lagrangian optimization principle. So here we utilize the fact that along this ray, the ratio between x2 and x1 is always same. So that is, in this case, the utility function, for example, is given as minimum ax1 bx2. So if utility function is given this way, along the ray that passes through the corner points of the indifference curve, the value of ax1 will always be equal to the value of bx2. So rather than utilizing the condition of tangency points, which is not defined here, we utilize this condition and the budget constraint of the consumer in order to derive the Marshallian demand functions. So now let us utilize this function. So our utility maximization program is maximize utility x1 x2 by choosing the value of x1 x2 equals mean ax1 bx2 subject to the budget constraint. The budget constraint in this case is P1 x1 plus P2 x2 is equal to the consumer's wealth. So now let us use these two conditions. The first condition is along the ray, ax1 will be always equal to bx2. This gives us x2 equals to a over b x1. So now we substitute this condition in the budget constraint. P1 x1 plus P2 x2 is equal to total wealth. So now P1 x1 plus P2 times the value of x2 comes from here. This is a over b x1, a over b x1 equals to w. So now this is x1 P1 plus P2 a over b equals w. So x1 bp1 plus ap2 over b equals to w, and this gives x1 equals w times b over BP1 plus AP2. So this is the Marshallian demand for x1, which can be expressed as x1, which is the function of P1, P2, and W, is BW over, we just rearrange this is AP2 plus BP1. So this is the Marshallian demand function for the first commodity. Now we substitute the value of x1 in this condition to get the Marshallian demand for x2. So this is x2 equals A over B times the value of x1, BW over AP2 plus BP1. So B gets cancelled, and the Marshallian demand function for x2, which is the function of P1, P2, and W, can be expressed as AW over AP2 plus BP1. So this is the Marshallian demand function for the second commodity. So now we can simply derive the demand function when the value of A and B equals 1, or when the utility function is simply given by U equals mean x1 and x2 only. So it is the special case where the value of A and B are same and equal to 1. So we have derived the formula for the Marshallian demand function. X1, P1, P2, W is BW over AP2 plus BP1, and the Marshallian demand function for the second commodity, which is the function of P1, P2, and W, is AW over AP2 plus BP1. So now in this case, the demand function will be x1 PW, sorry, this can be written as P1 P2 W, which is the value of V is 1, so this is W over P2 plus P1 or P1 plus P2. So this is the Marshallian demand function for x1. And the Marshallian demand function for x2 commodity will be x2, which is the function of P1, P2, and W, is also W over P1 plus P2. So if we remember these demand functions, we can write the demand function for any Leontief type of preferences. So now we can try to write the Marshallian demand function when the utility function is meaning 2x1, x2. So thank you for watching this video, and please subscribe my channel for further videos in the future.